Alright, the final example that I'm going to show you is a little bit more complex, but we're still using our basic trig ratios. So here's our setup. We have the angle of elevation from a car to the top part of the building is 48 degrees. If the angle of elevation from another car that is 22 feet directly in front of the first car is 64 degrees, how tall is the building? So when we get done, we want to be able to make sure that we can identify the height of the building. So I'm going to just designate that with a dashed line here. So what is that height? And because it represents height, I'm going to use h for that. And now, how do we use our trig ratios to help solve this? We're going to work with two different triangles. One triangle is sitting right in here with a 64-degree angle, and the second triangle is sitting in here with our 48-degree angle. So we're going to have to work with two different triangles to help us solve this. The problem is we end up with two unknowns. What we don't know is we don't know the distance from here to here, the green dots. So that's going to be x. So then when I'm looking at this and trying to figure out how to solve this, one of the triangles I'm going to use is the triangle with the 64-degree angle. So why did I do that twice? The tangent of 64 degrees is going to have to equal opposite, which is the h, over the adjacent, which is the x. The height of the building over the horizontal distance the first car is from the building. Then if I go to the second triangle, we're going to go the tangent of 48 degrees is going to have to equal, again, it's going to be the opposite side, which is the height of the building, all over the distance from the car to the building, which, be careful with this, because it's going to be x plus 22. So the distance is x plus 22. Now, if we have two variables in two equations, we can solve these, but we want to be able to substitute in for one. So I'm going to solve this one for the height of the building. And if we do that, we have to take x times the tangent of 64. So this is what we can use for replacement value over here by substituting in for the height of the building, h. So the tangent of 48 has to equal h, which I said I was going to substitute, x times tangent of 64 all over x plus 22. Now the trick is to isolate x and solve for x. So anytime we have x in the denominator, we'd like to get it out of there by getting it removed. So we're going to multiply each side by x plus 22. It's going to look like a little bit like some of those logarithm equations that we worked with in the previous one. Because now we have x's on both sides, so we're going to distribute the tangent of 48. So it's going to be x times the tangent of 48 plus 22 times the tangent of 48 equals x times the tangent of 64. So that x is on two different sides, so I'm going to move these over here so I can factor them out. So we got 22 tangent of 48 equals x times the tangent of 64 minus x times the tangent of 48. And then we can factor out our value of x. So we got 22 tangent of 48 equals x times the tangent of 64 minus the tangent of 48, and then we'll undo multiplying by that quantity by dividing. So in the end, we're going to do a calculation of 22 tangent of 48 divided by our tangent of 64 minus our tangent of 48. And that's going to give us our value of x, and x was a horizontal distance between the first car and the building. Okay, so when you do these, be careful that you enter them in your calculator correctly. Because I got a numerator and a denominator, I always like to encapsulate the numerator in parentheses of 22 times the tangent of 48. So remember, as soon as you get tangent, you're going to get a parenthesis, close it, because it's a 48-degree angle you take the tangent of. That's the numerator. It's not really needed in this problem, but like I said, I think it's good practice to make sure you get your numerator completely in parentheses, and I want my denominator completely instead of parentheses. So now I got the tangent of 64. Tangent of 64. Be careful you close your parenthesis on your 64. We want to subtract the tangent of 48. Make sure you close your parenthesis for the tangent of 48. And then we want to close our parenthesis for that's the last in the denominator. And we get 26.0015. So the length of x, or the distance from the first car to the foot of that building, is approximately, and this is to the nearest foot, 100th of a foot, really, 26 feet. So now we know that this length for x is approximately 26 feet. So we can use this now in our triangle to help us find our height. So if we use 64, that's the opposite adjacent, so the tangent of our 64-degree angle would have to equal the height of the building over 26, which means the height of the building has to equal whatever 26 times the tangent of 64 is. So we'll do a little calculation on it. It's 26 times, and if you wanted to use that answer, you'd be a little bit more precise, but since it's rounding off so small anyway, I'm not going to worry about it. And the tangent of 64, parenthesis, enter. So the height of the building is approximately 53.3 feet tall. Like I said, it's a little bit more complicated, but still using your same trig ratios that you've been using. Combines a little bit more equation solving abilities. So that's the last example. That should conclude everything that we need to discuss on that, and now you can work on that homework.